Welcome back to Machine Learning Guide. I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. Where your other machine learning resources provide the trees, I provide the forest. Visual is the best primary learning modality, but audio is a great supplement during exercise, commute, and chores. Consider MLG your syllabus with highly curated resources for each episode's details at ocdevel.com/MLG. I'm also starting a new podcast which could use your support. It's called Lefnir's Life Hacks and teaches productivity-focused tips and tricks, some which could prove beneficial in your machine learning education journey. Find that at ocdevel.com/LLH. You're listening to Machine Learning Applied. In this episode, we're going to talk about storing your NumPy and Pandas data onto disk. Now, here's the traditional workflow. First, you'll get your data from somewhere. You'll get your data set, they call it, your data set. That's going to be, housing prices and all their features, number of bathrooms, number of bedrooms, whatever. Or if you're doing natural language processing, it's going to be a corpus of text. Maybe it's just a whole bunch of text and you're, building sort of a text generating process. Or you're building a supervised learning, machine learning model, and what you have is a column of texts, okay, big paragraphs of sayings, and then another column of sentiments, whether happy, sad, angry, etc. Maybe you're building a sentiment analysis bot for IMDb reviews or tweets or whatnot. So the original data you receive from your customer or your client or from online will usually be in a spreadsheet, a CSV file, or a TSV file, tab separated values instead of comma separated values. Or another common format is called fixed width file, FWF. It's kind of like a TSV, except that it's not necessarily tabs. It could be like 10 spaces always indicates a break in columns. Or maybe you're getting JSON file from an API or data from a database. Okay, it could be any number of sources. Well, as with the last episode, the magic of pandas is that pandas can come in here and it has a function for reading any possible data set under the sun. You can read a CSV, you can read a TSV, a FWF, a database, a JSON API response, etc. These are all just one-liners. Okay, so it's like pandas.readCSV. And then it has all sorts of options for edge cases or file encoding or any sort of issues that you might bump up against. So you'll read in your data set through pandas, and then you'll munge your data, you'll impute your data, you'll remove rows which have missing values, or you may forward fill those missing values into the null slots, imputing your data. So you'll do all sorts of data manipulation in pandas before you want to feed your data to your machine learning model. Now, one thing to note, before your data hits the model, it needs to be numbers. TensorFlow and Keras neural networks, they can't handle strings. They can't handle true or false. Everything has to be a number. Everything has to be converted to a number. And so Pandas has tools for converting all of your stuff to numbers. If you have, let's say, categorical strings like male or female or other, or MSL for small, medium, large, etc., you can do what's called one-hot encoding these strings. The Pandas function for that is get dummies. It's kind of a weird word. I think dummies, it has a special meaning in statistics about indicator variables that are ones or zeros. So get dummies will one-hot encode your string variables, your categorical string variables, mind you, into numbers. And you'll just figure out what to do with all the other things. You'll turn your booleans into zeros and ones, etc. Pandas will do this all for you. So you'll turn all of your data set data into numbers through pandas, and now you can pull out of pandas your NumPy array, the array that's underlying your pandas data. All you have to do is say your DF, your data frame. Usually it's stored in a variable called DF. You just say df.values, and that's your NumPy array for all the data inside your data frame. And then you'll pass that ND array, your NumPy array, you'll pass it to TensorFlow or Keras. So you ingested your data set through pandas, you did your data manipulation through pandas. Now you have your clean data, your processed data, and you pull out the NumPy array version deep down inside, and you hand it off to Keras or to TensorFlow to crunch on those numbers. Now, TensorFlow and Keras both have the option of saving intermediate values of the training process of the model. Let's say you have a deep neural network that takes a very long time to train. Now, if it's maybe 1 hour, and that's kind of a long time, right? You go and you get a coffee, you come back and check if it's done. You don't necessarily need to save away the model. And when I say saving the model, I'm talking about the neuron weights, the weights inside of each of your neuron in a neural network. Those will be stored as NumPy arrays. Each neuron will be an array of weights. Every layer will be an array of those arrays. Okay, so now you have a 2D matrix. And the whole neural network will be an array of those layers. So a 3D array, a 3D NumPy array. That's how Keras and TensorFlow are storing in RAM the weights of your neural network. Now, if it takes an hour to train your model, you don't really need to save those weights away somewhere. But if it takes 3 days, you might want to save periodically your weights to a file or to a database or something, maybe once every 4 hours or 3 hours or something. Save those weights away in case any number of things, in case your computer crashes, in case you want to kill your model on the second day so that you can start using it in its current state. You're like, okay, you've had enough time to train. I'll just start using you the way you are. Then you'll want to pull those weights out from disk, load them up into your model, and then use them to make your predictions. Or what's called early stopping. If we detect that your model is training well on the training set, it's getting a very high score, a very high root mean squared error or accuracy score while training on the training set, but while it's testing how well it's doing on the validation set, it starts to do worse and worse over time. There's this curve you'll see online. It's kind of hard to describe. Your training error might come up from top and move its way down. So it's getting better and better over time. Lower error is better, and so we're going down over time. And then your validation error goes down too. It's going down alongside your train error. They're moving in tandem, coming down and down. But at some point, your validation error starts to go back up. It's like a parabola, like a U. And so it's at that bowl in the validation error where your model starts to overfit and it starts to underperform on the validation set. We want to cut it off right there. We want your model to stop training and use the weights that it had before. Well, it's very difficult to do that if you're not saving away your weights. Because if you're saving your weights, we say snapshot 1, snapshot 2, snapshot 3, we can look at the point at which we're doing worse than before and say, oh, look, 5 snapshots ago was the ideal. So stop training, delete the last 5, and roll back to what was saved on disk 5 network weight snapshots ago. So it allows you to roll back. All sorts of benefits to saving your neurons to disk. So that's a whole lot of stuff. I apologize. But now we're going to talk about how we save those weights. Like I said, everything's in a NumPy ND array in RAM. We're going to take that and put it onto disk. So the name of the game is storing your NumPy array. We have a whole bunch of options. In the neural network frameworks like TensorFlow and Keras, the library they use is called HDF. HDF. And specifically, the version we're on of this file format is HDF5. And so you'll see things stored as H5 files, or you'll see a library called H5Py. But the sort of core file format is called HDF. Now, this is a really cool sort of file format. What it allows you to do is you open up your HDF store, just like you would open a file for writing to or appending to in Python like normal. You open it, and now what it allows you to do is save NumPy arrays to a key. like a key value store where the value is NumPy arrays, you don't actually have to save the file explicitly. Every time you assign a NumPy array to a key in your store, in your HDF file, it will just save it automatically. So let's say you create an HDF5 store, and we'll just call it store. Say store equals blah, 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 blah to create one of these things. And it's tied to a file on disk. So you'll actually save a file on disk called something.h5. Okay, store equals, blah, 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 open, blah, blah, blah.h5. And then you'll say store.network weights equals the NumPy array of network weights. And that was it. It actually saved it to disk. It's really efficient. It's very good at storing NumPy arrays because it works with NumPy's knowledge of the data type of the data it's storing. So in the same way that NumPy is really good at storing data in memory, HDF5 is good at storing that NumPy data on disk very efficiently for very fast lookup and manipulation. It also has built in some really efficient, very fast compression utilities so that as you save this data onto disk, it's also compressing it on the fly. So if you're going to store NumPy ND arrays on disk, and that's pretty much it, you're just, for the most part, just storing ND arrays, then HDF5 is the way to go. And of course, as always with pandas, surprising you with the amount of functions it has coming to the rescue, there is a pd.toHDF function for saving your pandas data frame or NumPy array to an HDF store. Like I said, Keras and TensorFlow use HDF5 by default. So if you're saving your models away with Keras, you don't really have to know anything about the process. You just give it a file name and it will do all the work for you. But that's what it's doing, is saving it to an HDF file. And that's a very powerful file format for very efficient NumPy storage and manipulation. Now, the next option you could do is to store what's called a Pickle file. A Pickle file is a traditional Python file format for storing Python objects, Python numbers or dicts or arrays, anything that you constructed in Python, including a TensorFlow model in its current trained state, for example. You can save those away in a Pickle file. Now, Pickle is sort of a poor man's approach to saving data. Like I said, you can store anything, not just ND arrays. So if you're storing a lot of stuff beyond NumPy arrays, then it might be a preferable approach than HDF5. But it doesn't really compress well. It's the file format is actually known to be insecure, so be careful where you're storing these things if you have private data contained inside. And I don't know, for whatever reason, Pickle files I see tend to be used in industry kind of like training wheels until you can move yourself off of Pickle and onto a proper data storage format. You'll see people using Pickle in the first 10 to 20 commits of their repository, the first month of coding, and then they'll move away from Pickle towards something more dedicated to the type of data that they're storing specifically. So in the case of ND arrays, we like to store those in HDF5 files. And in the case of more heterogeneous mixed data, okay, not just ND arrays, but lots of strings and dates and any other types of data, we like to store those in CSV files, spreadsheets, or proper databases, SQL databases. And Postgres tends to be the SQL darling of 2018. There's plenty of competitors out there. There's Oracle and SQL Server and MySQL, SQLite, etc. A lot of people really gravitate towards Postgres. So HDF5 files for NumPy arrays, Pickle files for, look, you just kind of quick and dirty want to store some Python data into a file until you get a proper data storage solution in place. And then databases or spreadsheets for more production-ready heterogeneous data. Now, what I see a lot is people will store their data as CSV files, spreadsheets, if they want to send that to a manager or a customer. And then databases like Postgres sort of come into play at the end of the pipeline. Postgres, people will push the results of their machine learning model because we're actually now taking those results to production, okay? The data needs to get to the customer, or we need to share the data with fellow scientists or something like this. So usually what will happen is we ingest the data from a data set, we crunch it with pandas, we send it through our machine learning pipeline, we store intermediate steps using HDF5, and then we publish the results, whatever is the result of our machine learning model, into the database, into Postgres. So as an example, let's say the website Pandora, which is all about taking thumbs up and thumbs downs from people who are listening to songs and turning that into a new playlist based on a recommender system. What will happen is the user will either thumbs up a song or thumbs down a song. It will ingest that process into the machine learning model, crunch the numbers, maybe store some intermediate results in HDF5 files. And the result of all that might be to generate a new playlist, and we'll store that playlist in a Postgres database. So the SQL database is sort of the downstream end to your machine learning pipeline. Or, for example, clients that I work with who are very tech savvy and they're familiar with RDBMSs themselves, they know SQL. I'll send them the connection string to the database where I save the results of our machine learning models. So it's a sort of collaborative central location where the results of our models get published, and we can all look at each other's tables and see what kind of results the others are getting. Now, those aren't the only 3 file storage options in Python. Of course, there's plenty more. Those are 3 that are very common that you'll see. You may start to see some other competitors to HDF5 in particular. There's one called Feather, and then there's one called PyTables, which actually I think uses HDF5 under the hood. It's just a little bit more robust and feature-rich. So look into those offline, PyTables and Feather. But for the most part, the process is start with Pickle as your training wheels, graduate to HDF5 for your numerical storage, and then publish your results to a database, which is either going to be used by your app or your website, or going to be looked at by your fellow colleagues and researchers. Python, machine learning oriented file storage.